we are going to look at how to find equation of a tangent and a normal to a parabola by using implicit differentiation. First of all, let's define what is a tangent and what is a normal. So, assume we have this parabola. So, for us to identify the tangent line, it's a line drawn to touch any point on our parabola. So, we have a line. So, this line is drawn and it has touched a point on a parabola. And this line is what we call tangent line. So what is normal? Normal is any line that is drawn to pass through the tangent of the parabola, and that creates an angle of 90 degrees. So we have this. So this is a normal line. So what is the difference between the tangent and a normal? The difference is in relation to their gradients. So if the tangent has a specific gradient, comparing to the gradient of the normal, it will take the negative reciprocal of the gradient of the tangent, because the tangent line is drawn from different direction, whilst the normal line is also drawn from the opposite direction of the tangent line. So as the gradients are going to be different. So let's see how we can prove on how to get the equation of a tangent. This time we are going to look at using the implicit differentiation. So first of all, you need to take up this parabola, y squared equal to 4px. This is one of the 4 basic equations of parabola, and we are using this to derive the equation of a tangent. So we assume we have a point on this parabola. So how would the equation be derived? You know that before you can generate any equation of any line, you need to know the gradient. So the implicit differentiation is what we're going to apply to determine the gradient of the tangent before we can derive the equation. So by using implicit differentiation, we are going to use y squared equal to 4px, and we are going to differentiate this with respect to x. So at the left hand side, there's no x variable here. So in this case, I'm going to say that the differentiation of the y squared will be 2y dy dx equal to differentiation on the right hand side, we have 4p. Then we need to make dy dx the subject. So dy dx will be equal to, then divide both sides by 2y, and that will give you 2, so 4p over 2y. Then we simplify this. So our dy dx is equal to 2p over y. Then you are going to substitute whatever we have for y in the coordinates in place of the gradient. So y here we place with y1. So our final gradient or the slope will be dy dx is equal to 2p over y1. Alright, now we're going to determine the equation of this parabola using the standard equation of a straight line, and it is y minus y1 equal to m into bracket x minus x1. We are going to substitute the gradient into this equation. We have y minus y1 equal to, the gradient is 2p, so 2p over y1, then x minus x1. This y1 and x1 are the coordinates of this point p, so they are the same. Our LCM is y1, so we're going to use the LCM to multiply throughout the terms in this equation. And we have 1, 2, and 3 terms. So y1 multiplying y, we're going to get y1. Then this and this multiplies to be y1 squared. Then we have 2p x minus x1. Then we expand the bracket here. So we have y1 minus y1 squared equal to 2px minus 2px1. Then we make y the subject, y1 the subject. So we are going to have y1 equal to 2px minus 2px1 plus 2y1 squared. Alright, now this y1 squared is being compared to this equation. So this equation here can also be y1 squared equal to 4px1. So we are going to substitute, so but y1 squared will be replaced by 4px1. So wherever we have y1 squared will be replaced by 4px1, and we have y1 equal to 2px minus 2px1 plus 4px1. Then we add a coefficient, so we have this one with 2px, and this will give you positive 2px1. So you factor the common factor out, and this will give you 2p, and the remaining numbers will be x plus x1. So with this, we will say that this is the equation of the tangent with respect to this particular orientation of the parabola. So that means if you choose different orientation of the parabola, the equation of the tangent will be different from this. So this is how you can use the implicit differentiation to determine the equation of a tangent. First of all, differentiate the equation given to you, then that will serve you as a gradient. You substitute that gradient into the normal standard equation of a straight line, then you work out to get your final equation of the tangent. Now let's look at the equation of the normal to the same orientation of our parabola. So with this one, what we need is the gradient. So the gradient or the slope. So the slope of the normal is equal to the negative reciprocal of the slope of the tangent. So with this one, the slope of the normal will be, this is the slope of the tangent. So we have the slope of the normal will be negative y1 over 2p. And that is the slope of the normal. So using the standard equation of a straight line, you substitute. So y minus y1 equal to m into bracket x minus x1. Then our gradient here will be, so we have y minus y1 equal to negative y1 over 2p multiplying x minus x1. And this will give you the equation of the normal. So you follow up these steps and also try and work out the rest of the orientation and their corresponding equation of the tangent and equation of the normal. In my next video, I'm going to show you the next method on how you can also generate the equation of the tangent and the normal using different strategy, which is the slope method. Thank you very much for watching. Don't forget to like, subscribe, follow, and comment on my videos. Visit YouTube and subscribe to my channel. Thank you very much.